Okay, I'm back to talk about general JavaScript performance stuff, and to a limited extent also WebAssembly, but we're going to find out very quickly that you get much worse information for that. So I have started up a local server. There you go, I just use PHP because that was the thing that I had readily to hand. It'll just do it for me, which is very convenient. And there you go. So there's my nice little page which generates the random stuff and then resolves corner to corner. So I'm going to put the numbers up and then do a random test, and I can't miss. Of course I did. There you go, 56 milliseconds. Right, so it's somewhat useful to do this business. All that is actually doing is taking the one date time, so const d equals new, sorry, date, not date time. I got the wrong language there for a second. Right, so if we have two of these, which are, so it will invoke with no arguments, it will just be the current time. You can just get one minus the other. There you go. And that's the number of milliseconds between them. So here it took me 6 seconds to work out what I was doing. Pretty sure that's milliseconds, not microseconds. If I guess that, well, I can work it out if it isn't, but I think probably that was 6 seconds there that I took. I don't think I took 6 milliseconds to do those two commands. There are systems which use microseconds, and in fact, practically speaking, your computer is using microseconds behind the scenes. But yes, pretty sure that's milliseconds. So you can take those values at the start and at the end, and there you go. You've magically got the amount of time in milliseconds. But the other thing that you can do is actually profile it. So here I'm going to do it in Safari. The actual process is the same, more or less, in any browser. This one will be similar to what Chrome has because of the WebKit engine being kind of in common between the two. So all you actually do is you tell it to start profiling, which is this button here. You do the thing, and that's it. You can stop it afterwards. So this is the information that I've got on the basic browser behavior during the period. So here we've got a bunch of things happening at the layout and rendering layer. I would have to check exactly what these are. In fact, I think I can, yes, I can pull my fingers apart to zoom into these. So that's a little bit better. That's a little bit clearer for me. So yes, these are all rendering like events. It seems strange because it wasn't actually supposed to be rendering during this period, but it looks like it was still actually allocating the time for it. So each of these little green blocks will have been it deciding to do a paint somewhere on the view, and the red blocks are probably style recalculations, which can have an effect when you're dealing with a bigger page, but for this purpose actually don't matter. And obviously you can see all of this purple is JavaScript and events. So if we pull this up, there you go. So this is actually telling me what was in the JavaScript and events. You can have a look at the other things. Yes, there you go. See, I'd remembered correctly. It's the red is the style recalculations. I didn't actually see that there was a CPU before, but that's nice. That gives you a good idea of what's going on there. But normally what you want to do is have a look in the JavaScript and events section and see what's going on there. So this default view is the call trees, which is telling me what the top level action was that was being performed. And if you click on the disclosure triangle, it will go down into each of the sections. So here I've actually got an on-click which ultimately runs build context, but then it becomes async, which is why everything else all of the time here is in promise reaction job. So that's a browser built in, which is dealing with how the function works. So here it is. Here's the actual top point. At this level, it may be useful to start at the top and work your way down. Typically, that's the case if you have a lot of things in the current view. If you don't have a lot of things in the current view, it's really not going to tell you a whole lot, except that when you expand it, you can see how much of the parent it actually used up. So here I could see that 370 milliseconds out of 408 is in display, which is terrible. I don't want it to be doing all of that work. And yes, restore here, which actually is built in, which I'm a little bit disappointed by, but whatever. So if I wanted to find out what this is, that's what this little arrow is here for. So I can click on it, and there you go. So I've gone straight in, and you can see that what this is actually doing is this is doing the work to display the little red blotches that are on the view. So these CTX things, there you go. I mean, look at this. I've rather fantastically declared what it actually is here. So this is the Canvas 2D rendering context. This is a thing that you operate on like it's OpenGL. All that this does is say, I want to change the coordinate scheme, and then it is doing whatever the action is that's passed in, and then it's switching back to the original coordinate scheme. So probably in this case, it may be a bit expensive for me to keep shifting coordinate schemes. It might be something that I want to avoid doing. But yeah, I can't really tell at this point. And if I did need to avoid doing it, what I would probably do is store the last set of coordinates and just translate the difference. Because so where you have the ctx.save and ctx.restore, that's doing a whole bunch of work in principle. In practice, it might be doing a lot less. But in principle, it's a whole set of things, including the foreground and background color and an actual full translation matrix, of which I'm only setting the 2D position. So you could be doing all kinds of things like rotating, resizing, skewing it in different directions, but all I'm doing is just applying translate. I'm just moving it to a bit different location on the screen. So for my purpose, it might be easier to just translate and do the action without doing a save and restore. Okay, so going back to timelines, here I am. So as well as the call trees view, of course, yes, this is actually telling me that restore is the big problem. You know what? That is a thing that I will absolutely have to consider optimizing, because that is nearly half the total time that it accounted for. Although that might be a problem partly in relation to the fact that the debugger was turned on. Because one of the problems that you do encounter when trying to go over performance is that when you're profiling, it has to, at the very least, stop the program repeatedly and have a look at it. In the worst case, what it will actually do is it will have defined stop points which report back, and the cost of going into those stop points may be huge compared to the actual cost of doing whatever the thing is. So you can do inverted, do it the opposite way up. There you go. So restore, again, it's communicating to me here that restore is hurting me quite a lot. Translate is hurting me a lot less. Although again, from this perspective, given that I know how long, there you go. So it's the inner runtime there is actually only 77 milliseconds. So I know that the actual amount of time that it's spending doing work is a lot less than that. Although this, I think, No, this actually is just a straight line runtime. I was going to say that this might be added up between different chunks, but despite all of the gaps in here, this actually was just done in a single call. It wasn't done in multiple async calls because that's the point of turning display updates off here. So it did take 77 milliseconds. It just took longer while doing that. And of course, a thing to keep in mind with this is that the cost that's in here is actually just the cost of doing this this root calculation. It doesn't include the cost of starting up or the cost of rendering at the end. But so for my purpose, that number is the important number. But this cost here is a sad one. So I can extend this, I can expand this rather, to find out what was calling this. So we can see we've actually got two different display functions that were doing this. I can tell you that this one will be the one that's related to doing the initial display, and this one will be the one that's related to displaying each and every time it gets updated. Top functions, I think this is, yes, this will just be the top by total time. Yes, that's all it is. So this is in essence an expansion of the non-inverted view. So yes, events is the other view for this, but in fact that is not an exciting view because this is just showing you where the event started. So there are other possible views for this, but as it happens, they aren't ones that Safari implements. So I'm not going to show them to you right now. So in my case, I want to have a look at not doing ctx.restore as much because although it doesn't actually show me, and I don't think it'll, yeah, so it won't let me know. There are profilers which will give you more information than this, or at least different information. And there are profilers which will actually say how many times it entered. In this case, I don't get that. I only get to see the total time and self time. So yes, I'm going to work to reduce how many save and restores it does, and that will improve the performance. But that's something I will do offline because it's not something that's exciting enough to watch, and there's a whole lot of back and forth involved. So if you do have trouble getting information out of a profiler when you're looking at it in a browser, it's completely worth giving it a go in a different browser because a different browser will have a different profiler. But the thing to keep in mind with that is that a different browser will perform differently. It'll have different behaviors, and that will mean that it may be slow in different areas to whatever one you're primarily looking at. So they're not always comparable, basically. I'll look at the null test. I forgot I had that actually. So this is a test where you can only go corner to corner, and this is actually, I think, the worst case for the particular algorithm that I've built, which is why it takes so much longer. Whereas the ones which are random are actually easier because it has less choice. Okay, so that's it for today. Simple coverage of JavaScript performance. And in fact, actually, you know what? I'm going to say that's not quite all because I do really, really, really want to have a look at whether WebAssembly is in there. So I'm just going to quickly do that now. Right, stop. So that did have a hit, good, right. So I'm just going to switch this. Oh no, I want it not inverted. I'm going to have a look at what it actually did. So it's definitely not display that I care about. Oh, I did have a little bit of set timeout. Yeah, this doesn't seem to have actually accounted for WebAssembly at all in this case. This isn't a particular surprise because the WebAssembly is compiled and it will oh, okay, it'll naturally compile it in a form which doesn't really support well, it'll naturally do it in a form which doesn't really support doing profiling on it, because there would have to be injected stop points in there. I'm actually just going to, can I just show me top functions, because I want to scroll down here and see what everything is. There we go. Right. Okay. So we do have the WASM functions. These things are kind of nightmarish to look at, but all they're actually saying is that it is a function that is in a WebAssembly module, and that it is the sixth one. It's either the sixth symbol or the sixth function. And you can very quickly get to work out which they actually are if you're looking at the source code, because it can only really be one of those things. But yeah, that's all it retains for that. So my worst WebAssembly function is using 17 milliseconds for this operation, so I don't care about it. I'm just going to do one final thing. I'm going to do a test that's really, really big. Let's see what it does. I think it's crashed. I said 640k would be enough for everybody. I don't think it's enough for this. I think it's an amount that will not work for 2000. There you go. Took 750 milliseconds to do this 1000 by 1000 grid, which isn't too bad. I'm fairly happy with that. Okay, that's it. I don't know what I'll cover next time, but it'll probably still be something JavaScript related.